Hello and good morning to my lecturer, Miss Jayashari, and to my friends. Today, I want to present about report to survey Travers. Okay, my name is Muhammad Ashraf bin Muhammad Zaini. Number metric is 01DKA 19F 2015.
Okay, my name is Muhammad Arif Rika Biadanan. Matric number is 01DKA19F2027.
Okay, now the next slide is objective. Okay, we have 5 items to present. So number 1 is introduction. Number 2, equipment. Number 3, work produce. Number 4, data, and the last one is conclusion. Okay, the next slide is intro. Okay, traversing is a form of a control survey that requires the establishment of a series of stations that are linked together by angle and distance. The angle and distance are measured by total station. The use of traversing survey is very fundamental and has become one of the most common method in geometric engineering work, such as general purpose angle measurement. Number 2, provision of control surveys, contour and detail mapping, and the last one, setting out and construction work. This topic will describe about the construction and use of the total station in traversing, the traverse design, and the procedure of computing and adjusting a traverse. The application of coordinate 4 point will also be covered in this topic, which will be very useful in civil engineering project.
Equipment use is number 1, prisma. A survey plans reflect the EDM beam back to its source, which boasts a wide range of incidence and with high precision. Prisma predicts the scatter of the beam as if it reflects back to the total, which allows for both a more accurate measurement and a longer range that the measurement can be made. Theodolite. A theodolite is a precision instrument for measuring angles in the horizontal and vertical planes. Theodolites are used mainly for surveying application and have been added for specialist purpose in fields like meteorology and rocket launch technology. Tripod. The tripod is the base of financial that support the survey instrument and keeps it stable during observation. For the work procedure, what to set up total point, how to do total surface left and right observation, have to left and right. Step 1, set up the tripod on solid ground and settle it over the stone marker. Step 2, attach the lever to the tripod and tighten the center screw at the bottom of the blade. Step 3, press the tripod inward to hold it to the ground and also so that it does not move while carried outward. Step 4, line the tripod so that the bubbles is in the center and not shifting, and to make work easier, make sure the vertical bubble is in the center. Step 5, even if the lever is in the opposite direction, make sure all the bubbles are in the center. Step 6, check centering again. And step 7, check vertical bubbles again. How to do total station face left observation. Okay, step 1, target to back station prisma. Step 2, set back bearing. And step 3, measure distance. Step 4, target to 4 station, also known as prisma. 5 for bearing. How to do total station face right of slasher. Number 1, target to back slasher, also known as a prisma. Step 2, set back bearing face right. Step 3, measure distance. Step 4, target to for station prisma. Step 5, for bearing, also known as a face right. And step 6, measure distance face right.
Okay, the next slide is the data. Okay, so now you can see at the figure 1. Okay, and the box at the right have for data at figure 1. So lane UT, TS, SV, VU. Okay, distance for UT 364.55 and bearing 258 degree 34 and 22. Okay, TS 347.00, bearing 309 degree 5 and 38. Okay, and so on. And the total for distance is 1477.23. Okay, now how to define departure ED and latitude EL. Okay, now we go to the next slide to know calculate for departure. Okay, this is the first thing, formula. Okay, so the formula for departure is distance, sin, and bearing. Okay, and number 2, latitude. Latitude, distance, cos, bearing. Okay, so we conclude to all. So get for departure, for UT, negative 357.3236, TS negative 269.3114, for SV 254.6017, and the last one VU 372.1231. Okay, conclude for the all departure, get 0.0898. Okay, for the latitude, okay, latitude, you can see at the slide at 21, the same. Okay, so we get the conclude all the lane, and total for all latitude negative 0.085. Okay, after conclude that's all, we conclude for enclosure and precision. Okay, for enclosure, punca kuasa 2 EL plus 2 ED. EL for latitude and ED departure. Okay, so we get for enclosure is 0.029. Okay, and the last one, precision, formula is enclosure divide for distance. Okay, 0.029 divide to 1477.23, so get 1.963 multiply 10 kuasa negatif minus 5. Okay, for the check that answer is balance or no. So we go the next slide. Okay, this table check for departure and latitude is balance. Okay, how to check correction departure? So you can see the formula is ED. ED is departure. Multiply for ni apa? LSV divide to perimeter. Okay, so you can see at the right table. So we get the same conclude for departure and correction departure. So that answer is same 0.0898. Okay, for the balance, to know departure is balance or no, so you must minus to departure minus to correction departure. So conclude all get the 0 for the balance. So it is a balance. Okay. Okay, the next slide is latitude. Correction latitude. It the same for same at departure. Conclude. Okay, so the total for latitude and correction latitude is the same. Negative 0.085. Okay. Okay, to check balance for latitude, the same thing at departure. Okay, so we conclude latitude minus to correction latitude get 0. So this value is balance. Okay.
Okay, for conclusion, correction to latitudes and departure are used to balance a traverse. It is known as traverse balancing. The algebraic sum of latitude and departure must equal 0 in the event of a closed traverse L, O, and DO. To put it another way, the sum of the north string should equal to total of the south strings, and the sum of the east strings should equal the sum of the west strings. It is obvious that the closing arrow should be distributed across the traverse in such a way that its impact on the plane is minimal. It is calculated the overall inaccuracy in latitude and departure. These inaccuracies are then proportionally dispersed throughout the traverse station. This can be done mathematically by following a set of rules. The following are common methods of adjusting a traverse. Number 1, Bode's rule. Number 2, transit rule. Number 3, third rule. Okay, that's all from me. Thank you.